All right, thanks for coming, guys. My name is Grant. I help organize this meetup. I see a lot of first-timers here. You put your hand up if it's your first time. Yeah, that's what I thought. Well, yeah, Ethereum's been getting real popular lately, and it's exciting new technology, and thanks for taking time out of your night to learn more about it. So, yeah, I hope to see you guys at future meetups. And I'd also like to thank Digital Garage for being gracious enough to let us host our meetups here. And with that, I'll pass it on to Ron, who will tell you more about the speaker and project. Okay.
Yeah, thanks for having me. Yeah, thank you for the applause. It's really nice. I would like to get you to applaud more for Digital Garage because they have been they step up, they let us host these, and they're really encouraging, and they're super helpful, and they have great equipment, and it really helps us put on good meetings a lot more easily. So, Grant asked how many people was their first meetup. It looked like it was about 30 or so. I'm curious how many people here work with blockchain professionally. Okay, quick show of hands. Let's see if there are slightly less, let's say like 25-ish. All right. How many people want to work with blockchain? So let's say about 50-ish, it looks like. All right. That's good to know. So my last question is, how many people know about the company Consensus? Roughly about 50. All right. So I'm hoping that of those 50 who raise their hands say they know about Consensus, a good portion are people who are working blockchain or want to work in blockchain, because we just moved out to the Bay Area, and we are looking to attract awesome people who are technically talented, which I'm assuming there's a lot of very good technical talent here, and even folks who may not be as technically talented, their skills are elsewhere. Yeah, so we're growing. Some of the things Consensus does is things like Grid Plus, which are deeply systemic changes to the world. It's going to decentralize utilities and decentralize electricity, and it's things that are going to be talked about and have deep change. So we do a lot of other things Consensus, things based on giving everyone an identity on the blockchain, basically just laying the framework for a new economy that shares ownership and value in a much flat distributed manner. So come join us for the ride. We'd love to work with y'all. If you are happily working somewhere else, then stay in touch. Follow what we're doing, because we got good stuff cooking like Grid Plus and other things. So without further ado, we have Alex Miller here. Alex just moved to the Bay Area, so I want to give a little round of applause for Alex. Another kick-ass talented engineer in the Bay Area. And this one in particular, he almost switched his career to data science about 2 years ago, and instead found out about this thing called Ethereum, and I think he's been much happier on this path. So very pleased to have him here, and I'm going to pass over to Alex. Thank you.
All right, everyone. Thanks for coming out tonight. Thanks for having me. I'm Alex Miller. I am the lead developer at Grid Plus, a consensus project. And today I wanted to talk about how I view Ethereum and how I think we as developers can leverage it, and that is as a public utility. I'm going to twist on words there because I'm also building a utility, which I'll get to also this time. Okay, so who am I? Tech lead at Grid Plus. I kind of identify as a web developer by training. I do some other stuff, but mainly web development. I have authored a lot of technical blockchain articles. Perhaps some of you have stumbled upon a few of them. I really enjoy doing that. And I like seeing new developers in the Ethereum space. And I'm a consensus member. I joined consensus about a It's been a wild ride, a lot of fun. Okay, so today I have three little micro talks that I kind of want to tie together into how I view Ethereum and what we're doing at Grid Plus, and kind of an example of using Ethereum in what would otherwise be a kind of traditional application and system. Okay, so the first part is, what is Ethereum? This may be useful for the new people. So when I think about Ethereum, I think of it as I mentioned, this kind of public utility. It has a few pieces to it. It is this peer-to-peer network. So peers all over the world share this global state, and they can execute operations and code in a shared virtual machine. And the data that goes into Ethereum and stays there unless it is removed is the data structure that stores that is called blockchain. So lots of people like talking about blockchains. They're really just hash-linked data structures. They're not a business panacea to solve all of your problems. They're really just not that exciting in and of themselves. Ethereum is very exciting. It is a public network. So the most powerful thing about Ethereum, I think, is that it is a tool that developers can leverage today. So you can offload some of your tasks that would otherwise be expensive and laborious to Ethereum. So things like cheaper payments. So this is what Bitcoin promised 8 or 9 years ago. I think Ethereum is maybe even a little bit better at it because you can do stable tokens natively, which is, I think, the sort of onboard to a more mainstream adoption that we need. So I'm super bullish on stablecoins. We're actually building one at Grid Plus. Another thing you can do is immutable storage and computation. So once you deploy a smart contract, a piece of code that lives on a blockchain, you know that it will execute as specified. So once deployed, you can't change it, you can't delete it. The code lives there forever. So all that in mind, you have to pay for your computation, and you have to pay a lot. So people will talk about what Ethereum can disrupt, and a lot of people would say everything. But I'm not one of those people. Ethereum can disrupt a lot of things, and I think a lot of these things are sort of low-hanging fruit, and we'll see a lot of them take shape over the next couple of years. I mentioned payments. Anything having to do with manual tasks, so things like credit reports, which I've had to do recently because I just moved here, and it was more expensive than it should have been. Background checks, any sort of identity disclosures, things of that nature. Registrations, all of these sort of bureaucratic minutiae can be much more easily and cheaply automated on Ethereum and blockchains in general. Governments, I put that one in there. I don't think this is happening anytime soon, but I kind of think that this is perhaps where we will go eventually, because you have the purest form of democracy when you have properly identified actors on Ethereum who can cast their votes in an immutable fashion. So all the things that tie this, or the thing that ties all these things together is these are all non-repetitive tasks that require either legacy Rails or human intervention. So these are processes for which there aren't any good automated schema. Ethereum and blockchains in general are very, very good at making those more efficient. So things Ethereum can't disrupt. It really bothers me when I hear people talking about machine learning on smart contracts. That doesn't make any sense. Uber and Airbnb, a lot of people bring these up. I don't think that's going to ever happen because Uber does a lot of AI with its search pricing and things like that. Interestingly, I think Ethereum could disrupt the payments part, and especially for Airbnb because they do international Airbnbs, and international payments are really expensive. I think they're actually looking into it. But as far as the underlying AI, probably not so much. Google, yeah, also doesn't make sense. The internet, so I hear a lot of people talking about Ethereum being the next internet. I know what these people are trying to say. It's not very precise. So first of all, What they really mean is Ethereum is the next web. And I would argue that while there are these services and projects that are building a new kind of web, that's not going to happen anytime soon. It may take half a decade, maybe a decade. But Ethereum can augment the existing web very, very nicely. So that's what we're going to talk about this talk. Computation on Ethereum is expensive. I can say this many times. I want to drill down that message. Repeatable computations are just not a good idea. Okay, so augmenting the existing web. There's a ton of cool stuff you can do with Ethereum today. And again, this comes from the fact that you can leverage it as a public utility. So you can outsource expensive tasks like the ones I was referring to, things like payments, registrations of your devices, of yourself. These are sort of like one-time tasks that you usually have to rely on some third party to do and integrate them into Ethereum. When you put data on the blockchain, it is immutable unless you encode some way that you can pull it out. But just be careful with that because it's very, very expensive. So only put critical data on the blockchain when you use it. So things like identities make a lot of sense. Things like your registrations. And then make sure if you have sensitive data, you want to encrypt before writing to Ethereum because anytime you make a transaction, the transaction itself is public. So just always be aware of that. One thing I like to do is identify users by their Ethereum address. So I think that this pattern doesn't get enough recognition, and I think it will in the future. You can have your legacy database. You can have a SQL database that runs your application. You can also use Ethereum. You can use the identifier between both to refer to the same individual. So your users now don't have to use passwords, which is super cool. MetaMask or embedded wallet. So every time you develop an Ethereum app, you have to interact with the blockchain somehow. That means you need to put in some sort of a wallet or some way to use a private key. MetaMask, if you haven't heard of it, is a consensus project, and it's a browser extension. So you can just, it injects the Ethereum state into your browser, injects Web3 rather, which is an API to the Ethereum state. And once you have that in, you can interact with Ethereum. You don't have to build your own wallet. It's really, really cool. So your users need to be onboarded once, and they can switch between apps very easily. If you must build an embedded wallet, like if you're doing a mobile app, that's fine. It just depends on your UX. So be aware that there are lots of options here. Always store your keys on your device. Do not send them over APIs for any reason, even if they're encrypted. You just don't want that liability. Just keep them on the device. So signing key derivation libraries, there's lots of cool libraries for doing crypto stuff. In JavaScript, there's Ethereum.js, ETH.js, which is surprisingly a different set of libraries. And then there's Web3.js. And kind of tangential, I don't know why you would do this, but don't ever roll around crypto. There's no reason to do that. It works very well. Okay, so those are kind of tips and tricks for Ethereum, kind of how I see Ethereum and its utility. Now I kind of want to switch gears and talk about Grid Plus. So I'll talk about how our system works, but before that, I want to give you an idea of like what we're doing, why we're doing it, where we want to go in the next couple of years. So the existing electricity supply chain can be broken down into four main parts. So three of these are controlled, three of these are actual infrastructure, and one is sort of a layer above that. So upstream, you have your power plants, your generators. These are anyone who can produce more than a megawatt. That power gets transmitted over high voltage lines, and that goes over long distances where it is stepped down to low voltage lines and distributed short distances. So long distance would be like over the desert, and then once it hits San Francisco, it would move to a distributor. So that's essentially the grid. There's three main entities, and then the last one is called a retailer. And now retailers are only responsible for billing. They don't own any infrastructure. They really just aggregate your costs. They read from your meters and they send your bill at the end of the month. And generally for that service, they will charge somewhere around 100% markup, which is insane. So half of your bill is going to the retailer. And so we want to be a retailer and we want to charge a little bit less than that. So why are they so expensive? Retailers have to, so when I refer to retailers, I'm specifically mentioning ones in deregulated markets. So these are ones where you have open competition. There are lots of states where you have basically government-sanctioned monopolies, but Texas and I guess some parts of California, you have these open competitive landscapes. Retailers have a tough time acquiring customers because they don't really have a way to differentiate their product because a lot of them use the same technology stack, which is super inefficient and runs on these legacy systems, and there's a ton of admin work in the background. So it's they have to resort to these gimmicks like giving away free Nest thermostats and things like that. It gets really pricey. They also have to hedge against bad debt, so they're not sure who's not going to pay them at the end of the month, and they have to charge everyone a little bit more based on some risk assessment algorithm. So we want to, in the short term, we want to operate as a retailer in Texas. Texas is where we're going to start. We may potentially move to California if the regulatory landscape looks favorable, but we are going to start in one state. We want to be a traditional commercial retailer that sells you power. This is an application to Texas ERCOT, which is their independent system operator. So once we do that, we can start signing up customers. And so it's really that simple. Where our efficiency comes from is Ethereum. So we want to leverage the public Ethereum network and reduce costs of electricity. So this is short term. Since we're using payment channels, that's 2 transactions, one to open them, one to close them. Your per unit cost approaches essentially 0 if you leave it open for long enough. There's no admin work because, as I mentioned, if you outsource things to Ethereum, you don't have to do these manual or these tasks because you are paying this network to do that. So you can kind of give a schema to this process. Also, customers hold their funds by the nature of how blockchains work. This is a totally different sort of risk landscape that's a lot easier to manage. We are going to require a deposit, so all of our energy is basically prepaid. And because we're holding this deposit, there's really low risk of any default, so we can drive down costs by not hedging against bad debts. And the whole idea here is that we're exposing customers to wholesale markets. That's kind of the crux of what we're using to kind of drive this future of a peer-to-peer grid. So that's the key here, and that's also going to drop costs by quite a bit. So what you do when you expose customers to wholesale markets is you incentivize them to buy solar and trade peer-to-peer, and also storage as well. So now your customers can run energy arbitrage every day. They can buy when it's cheap at 8 a.m., and they can sell at 7 p.m. when the price falls. So through all of this, we think that we can get the cost down by about 40% relative to traditional retailers. Depends on the market, but we're kind of gauging for Texas. So the way that we do this, and kind of a bit of a longer term goal, is that we use this thing called a smart energy agent. So this is just a general purpose computer. We are going to attach a secure signing encode so that you can do cryptographic signatures in a secure, trusted environment. And the intention of this is to sort of like bring you smarter consumption patterns because you're exposed to these markets. This thing should be incentivized to get you the lowest price possible. Based on previous consumption, based on any data you give it. Like so, for instance, if you're going out of town for 3 days, it probably doesn't need to turn your air conditioning down to 68 degrees if you're in Texas. These things get smarter over time. They are autonomous actors. We like calling them agents because this kind of brings an identity to the household. And of course, they're Ethereum aware, and we think this opens a pretty interesting IoT kind of topology for your household. So again, when you expose customers to like open markets, you're incentivizing storage. You can do that arbitrage. You're incentivizing purchasing of solar because now that's a revenue stream. And generally, when you expose things to open markets, you can sort of eke out efficiencies. So the agent, because it's just this general purpose computer that we're putting in these people's houses, we want it to be capable of becoming a node on some of these distributed networks and just introducing more and more sort of passive revenue streams. So you have this little device. You can imagine that you might add an SD card, get like a souped up model, and now you can be an IPFS node because you're able to store and serve files as a file. If Infura ever comes out with their pay-per-use API, Infura is another consensus project. I would like them to come out with that. I don't know if they're going to. But if they do, you could run a full node, and you could earn Infura coin by serving up Ethereum requests and basically functioning as this node from zero clients like MetaMask. These can also be Casper nodes, so you could actually secure the very network that you're using for payments by adding funds and staking in Casper. So the idea here is that you have this device. All actors on Ethereum are really just private keys. So this device has a private key. It is an actor on Ethereum. It is the identity of your household, and it's also your passport to these networks. So further along in the future, this is where we really want to go. We want to enable this peer-to-peer electricity market. We think that this really can happen and that this is a long-term economic equilibrium. The reason we think that is because it turns out that moving power over these high voltage lines from the power plants to the distributors results in a ton of electricity loss. It results in about 38% of your bill comes from just transmission loss. So I talked about retailers are 50% of your bill, 38% is coming from transmission loss. You're left with about 12% that's actually paying for the electrons that are arriving at your house. So if you incentivize solar and storage, your customers turn into prosumers. So you shift the demand away from the sort of upstream generators to more localized production sources. And this is nice to think about, but it's actually like more efficient because you aren't transmitting over distances. You're just transmitting potentially from your neighbor's house, which is a lot more efficient. So I want to clarify here, we do still want to use the existing grid. And the reason we want to do that is because this works really well. Like you may have noticed that your power doesn't go off every day. The bills are, like, while more expensive than they need to be, they're still reasonably inexpensive. So the grid works really well. But we think we can drive efficiency up and also drive a renewable sort of revolution, if you will, at the same time, because that is economically where we think we will go. And the result of this is that we're just less reliant on upstream generators, and the grid becomes more decentralized over time, which is kind of the mission statement of this whole space, I think. Tangential goal here, but I think it's super cool. We want to bring stablecoins to rating. So we want to sell this product to normal, like, commercial consumers. They're not going to want to pay Ether because they don't want to incur currency risk, and that's confusing. So we just want to sell them gold tokens. These are backed by US deposit for all intents and purposes. To the customer, they just look like dollar signs. In the back end, we use Ethereum for payments. These are ERC20 tokens. They can be redeemed by any Grid Plus customer. Being a utility, we have to KYC all of our customers. We think that's fine because it enables this full cycle of the Bolt token. So as far as like accounting, anytime that a customer pays us for like, for example, a credit card or something like that, we would mint Bolt tokens, send those bolts to the user or to their agent device, and then it would use those to pay for electricity over a payment channel every If any Grid Plus customer wants to redeem those bolts, we burn them, give them the cash. Similarly, if we need to pull out cash to pay for operating expenses or for the electricity that we purchase upstream, we would burn the bolts. So there's always a 1-to-1 ratio between bolts and dollars in bank account. And that bank account is audited by law in every region we operate in. So because all of our revenue comes from these bolts, we have a lot of bolts, potentially. We have a lot of customers, which means that we have this huge liquidity pool of these stable tokens sitting around. Wouldn't it be cool if we could use those in a rating hub on a state channel network? So that's what we want to do long term, and we want to introduce stablecoins to Raiden to run generalized commerce through Ethereum at a very low rate and to compete with traditional payments processors, which are surprisingly expensive. We have a token sale. They're basically prepaid energy tokens. If you're interested in this, I encourage you to read our white paper. Go to our website, subscribe to our mailing list, and then if you'd like to join our Slack and come chat with us, we're always available to answer your questions. Okay, so now I've kind of talked about what we're doing, why we're doing it. Since this is a developer meeting, I thought I would talk about how a customer would go about getting set up with Grid Plus, kind of what our prototypes look like at the moment, and then just like workflows of our system. I think this is helpful to see an example of how like Ethereum is used in a regular application. So I mentioned we have this agent device. We, as Grid Plus, to start this whole process off, would whitelist a serial that would be associated with a particular physical device. That device would get printed on the box and shipped to the consumer. Before it gets shipped, we also generate a setup key on device, and this is just a one-time key to throw away. We seed it with a very tiny amount of ether for a gas cost to set up its own key, essentially. So we at that point ship the agent. The customer would get that, plug it into their wall, connect it to Wi-Fi. At that point, it's all automated. So the agent would replace its private key. So we now no longer know what the private key is. It's an agent. It would remap its serial number to that new private key, and then it would throw away the old key. And then at that point, the agent's done. It's just sitting there waiting for the owner to claim it. This is what that looks like in the terminal at the moment. We have, if you're interested, on our GitHub page, we have a little client that you can check out. It'll always be open source, so if you want to be a Grid Plus customer and you don't want an agent, you can always load it onto a device of your choosing. Okay, so as a consumer, now you have this agent plugged into the wall. What do you need to do? We have a mobile app that is in very early stages of prototype development. That's why there's that purple eggplant background that will change. So we have the customer download that app. And the first thing they need to do is they need an identity on Ethereum, because they need a way to associate themselves to this agent device that's going to be purchasing energy on their behalf. So the way that you do this is one way to kind of set up a wallet on like a mobile device. A lot of wallets, I think, have shifted to using BIP39. This is Bitcoin Improvement Protocol. This is where you see those word mnemonics. So it's like between 12 and 20 words, and those get converted through some protocol to the private key. Specifically, the PBK DF2 curve would take the word mnemonic, add the actual mnemonic as the salt, and then hash that, and then do some crypto on it that you don't roll yourself. And it would generate a 64-byte private key. Fun things about being an Ethereum developer, you run into gotchas like this. You need 32-byte private keys in Ethereum, so I don't think there's a standardized way to do this, but what we do is just leave off the latter half of that. If you can think of a standard, you should propose it. So once you have your private key, you need to derive a public key. You use the SEC P256K1 curve. It does some other magic crypto. I don't actually even know what it does, but it's crypto that has been developed for 30 years. This is why you don't build your own. Once you have your public key, you can derive an address from that. It's a CAC 256 hash with the first 12 bytes removed. So there's like a lot of low-level protocol kind of stuff like this that you just get used to being in the Ethereum space, being an Ethereum developer. You get used to it. It's not that bad. So once you have your Ethereum identity, you need to type in your serial number. And again, this will be printed on your box. This is the last step to getting set up with your device. You type it in, it gets hashed and compared against the one that we whitelisted. If they match, then you become the proud new owner of this device on the blockchain. And you can, if you sell that device later, you can transfer it. Okay, so that's getting set up on the Grid Plus app, and then we have basically just our home screen because we don't need to do too much from this because the agent is actually the real identity that's doing all of the Ethereum payments and stuff. This is just a monitoring service basically for set preferences and things like that. So nothing too exciting, but that's basically how a Ethereum mobile app setup would typically go. Okay, so once you're set up, the agent is free to purchase its electricity. So it does this by opening a payment channel. So I hear a lot of people talking about Raiden. Everyone's very excited. I'm very excited for Raiden. But I don't think enough people fully comprehend that you can just make payment channels today. It's actually very easy on Raiden. There's a lot of different ways to do this. Payment channels are just a subset of state channels, where the state is just like the balances of the token. I have this picture of Lightning as an ode to the Bitcoin Lightning Network. So in the Grid Plus system, the agent would open a payment channel whenever it receives bolts. Bolt is, again, that USD token. So it opens the payment channel. It pings the Grid Plus API every hour or so. It would receive a bill in response, and that would have the data of how many kilowatt hours it consumed, the price of electricity, and then also the price of the market. Oh, and I forgot to mention, when you open a payment channel, you're actually depositing those bolts. So just quickly, for edification of anyone who doesn't know, payment channel is a way to scale out payments on Ethereum so that you don't have to make much of on-chain transactions. So you pay one transaction to open this payment channel, you deposit a number of your tokens. At that point, you can sign messages with your private key, send them over HTTPS, and the recipient can verify by playing that onto a constant function in the smart contract, the payment channel smart contract. They can verify that if they took that message, they would receive the number of tokens that you had pledged to give them through that message. They would accept that. They don't have to close the payment channel, though. They can wait for you to send 10,000 more messages, and eventually they would close that. So that's basically all we're doing. Every time it gets a bill, it just adds to that previous payment channel. Eventually, the total amount would reach whatever they deposited, and they would just close that. And then basically rinse and repeat. It's a very simple process, but it's really powerful because it drives the cost of these transactions down to nearly zero. And that's just a function of how many messages gets passed in the average payment channel. Okay, so just some things I wanted you to take away from these 3 little mini talks. Ethereum, in my opinion, is most useful for non-repetitive tasks. And these are anything that use older systems, legacy rails, or really more importantly, in human intervention. So Ethereum is sort of a schema for processes. As far as Grid Plus goes, in the short term, we just want to be a commercial electricity reseller. We think we can introduce efficiencies into the market by using Ethereum and by using a different as to how we operate. In the long term, we want to enable a peer-to-peer grid that can use existing infrastructure because we think that this is the economic lowest energy state. So we think that we will get here. Stablecoins, I think, are crucial for mainstream adoption, and they can be done natively in Ethereum. They're really exciting. There are other public stablecoin projects. There's Maker, which is one, and then Variable, which is also a consensus project. These are, and then there's Digix, I guess. Gold is kind of a stablecoin. These are different approaches to kind of the same thing. We're using a model that's similar to Tether. I don't know if you've heard of Tether, but that's built on the Omni layer. A lot of exchanges use that for instead of dollars. There are different ways to do stablecoins. We're doing sort of the Tether option. But however you do it, I think they're super important. And then payment channels can be built today. So you can go home, if you know Solidity, you can build a payment channel and integrate it into your app. These can be upgraded to RAID later, so you can get this more complex topological network from RAID, this general purpose state channel network. But you can focus on just putting in kind of dumb payment channels today, and they can do a lot for your bottom line if you're doing payments. We at Grid Plus are abstracting all of this crypto stuff away from the general consumers. They won't know they're using crypto. They just have this little box. It pays for the electricity. They send it money every month, and that's it. And by putting this piece of infrastructure in your house, we think that this could be really like the AOL CD of the crypto world. It's just this like critical piece of infrastructure that's been missing up to this point. So we want this to be ubiquitous. And then yeah, check out gridplus.io. Come read the paper. It's super long, but it's worth it. Subscribe to our mailing list, join our Slack, etc. Yeah, thanks for having me. And if you have any questions, happy to answer.
Are you worried about the privacy concerns of using one account for one household and having all their electricity usage be relatively public? I can imagine an attacker might be paying attention to electricity usage and know about home or vacation.
Yeah, so the electricity usage itself doesn't go on the blockchain. That's through a RESTful API. The payments also don't really go on a blockchain because we're using the state channels and all of the incremental messages are done off-chain. So the only things that are public are the opening of a payment channel and the closing of a payment channel. So that abstracts a lot. Yeah.
What are some cases where normal homeowners have a surplus of energy to sell back to the grid?
Yeah, it's a good question. So it's a function of how much solar you have. It's a function of how much you're using. I guess if you're out of town or if you're at work, during the day, if you're not consuming a lot, you could sell it to local businesses who are. It's not really like a 24-hour kind of deal, I guess.
Are you generating bulk or ether in that case?
You would be generating both, yeah. So another thing I can mention is that we will accept payments in ether, but we're not going to like make our customers be exposed to that. But yes, everything runs through. Yes.
Sort of a silly question, but if someone loses their key, is that a risk you're going to worry about and helping your customers there?
Yeah, great question. I should have mentioned that actually. So one thing that's kind of scary with developing apps on Ethereum is that if your customer loses their key, you can't help them because the design is so that you aren't exposed to that risk of having the key. The way that we're looking at this right now, we're going to put a blog post out. There is this cryptographic scheme called Shamir secret sharing. You can cut up a private key into in slices and set some thresholds such that if that threshold is met, you can recover the entire secret. If it isn't, you don't get anything. So you can set up, in our case, it would be 3 different devices. One would be us. You could also set up, you could take us out of it. You could set up a 3rd device, like your mom's iPad or something like that. And you could combine those together to recover your keys. So that's probably how we're going to do it. Yep.
So you estimated a 40% cost savings.
Yep.
What portion of that is from using Ethereum? And what portion of that is from the agent?
So the question was like, we have a pretty high number of estimated cost savings. What portion of that is from Ethereum? I don't have a very good like numerical answer for you, but in terms of cost savings relative to legacy Rails, I've worked with a traditional payments processor, and transaction fees were on the order of like 30 cents per transaction, possibly plus some percentage, like 1 or 2%. So it's a function of how many transactions we were doing, because we want to. There's a lower risk profile if we do a lot of transactions like once every hour, and since we can do that for free with payment channels, we're going to go ahead and do that. I would guess if we were doing the same sort of setup with a traditional payments processor, it would be really, really expensive. It would be a high percent. I would guess that somewhere around like a third would maybe be Ethereum related, but it's mostly a function of that marketing cost. So we can drive the marketing cost down by just having a more compelling sort of product and or price point. We can diminish that cost even more.
So you probably covered this in the paper, so I'm just showcasing my ignorance. But to me, it seems like one of the juiciest early pieces you can add is going to be creating intentionality between arbitrage for day-ahead and real-time energy markets. I'm just curious what if you already captured that in your strategy, or how you intend to work with your customers, because that's obviously like a huge piece of the cost.
Yeah. So the question was, a huge cost savings is going to come from purchasing in real time versus day ahead. Is that what you're saying?
Well, or just so right now, obviously, there's a million algo traders out there just doing arbitrage between those two, and so, but what they're doing is they're just doing regression. Well, they're doing all sorts of things, but you can add intentionality. So now you can take the battery of the storage and say, oh shit, prices are deeply negative right now. Go turn on your fucking washing machine because you're gonna get paid to do it. Just run it empty. Like,
Yeah.
but there's a lot of money out there in that.
There is. The short answer is that there is much work to be done on the AI side, but that is certainly like within the scope. So we would be monitoring real-time and day-ahead markets, and that would be used as obviously the data stream from which we decide whether or not it's like worthwhile. So yeah.
So there's that trouble with keeping your bank accounts open. So how are you going to deal with that risk of having their funds frozen?
Oh, how are you going to deal with the risk of having your funds frozen in the bank account? So the idea here is that we are operating as a traditional utility. There isn't a huge amount of risk associated with like having a central bank account. These things have to be audited. So we are, I guess, going to, I guess by like working in sort of like a traditional realm, I think we're not exposed to a ton of risk, I guess, would be the best answer, I guess. We're working with lawyers, is the good answer. We don't see a ton of trouble with it at the moment. Yeah.
Hey, say you were going to enter into the Ethereum market first, and your savings are going to come initially in short control from lower marketing costs. Have you looked at what your costs are compared to other retailers there? I mean, the main cost components are generation, T&D with on-board, regulation, and then it seems like you're going to see some cost competitiveness with, using the blockchain for maybe accountants admin. Have you figured out what that's going to be? Because it sounds like the growth is going to have to happen by that difference, because you're not going to put money in the market, you're not going to put your name on a stadium or anything like that.
Yeah, so I guess the question was essentially like where are the cost savings coming from relative to like other retailers?
Well, I guess one of the questions is, have you actually done the analysis on how much cheaper you're going to be? Because you're going to have to get mass adoption from being, paying less per kilowatt hour than the other cheapest option.
Yeah, so we're we're kind of like hyper-focused at the moment on deploying in Texas. We are focusing on acquiring like 5,000 customers to start with. Marketing costs are going to be really high to start with, and we hope that those will decrease over time. We think that there is serious efficiency to our systematic approach relative to the others, and a lot of that is having to do with that, and not using legacy rails, which are surprisingly expensive. Yeah, in fact.
Do you think that like this project will ever need to connect to any other blockchain besides Ethereum?
I do not. So the question is, do I expect that this will need to connect to other blockchains? I don't. I mean, you could make the argument that it could, but we are really just using Ethereum for payments and registrations at the moment. I guess if we worked with partner utilities and they were using other blockchains, perhaps. Yeah.
Could this project be developed on any other blockchain?
Sorry, could it be what?
Could this project be developed on any other blockchain, assuming they could execute smart contracts?
Yeah, absolutely. The question was, is this being developed on other blockchains? The answer is yeah, sure.
Yeah, you mentioned Bolt. Is that already live? I've never heard of it. Bolt stablecoin.
No, it's not. It's not live. It's part of our internal system. It will be launched when we have customers and they pay us. Yeah.
You talk more about your approach to the stablecoins and how there are some variance of 10%, upper lower bounds. I'm just curious, like, what your thoughts are on some of the limitations of that model, or maybe some different stablecoin models that, in theory, can be better.
Yeah. So I'm not familiar with what you're talking about with Tether.
It trades at values that range from like plus or minus.
Oh, so it just trades different than the dollar, and that's just a function of like how much risk they see in it,
Right.
and the markets also. Yeah. So the reason we're doing the one-to-one peg basically is that we think it's the most scalable option. So I talked about Maker and Variable. These are both models that use over-collateralized amounts of Ether or some other token of value, and basically can guard against like excessive fluctuations in the price. If you're interested in that, I'm certainly not an expert, but if you go read the Maker white paper, you will learn a lot. And then the other one, there's a company called Decentralized Capital that I think is doing also a one-to-one peg of basically you send them dollars, they send you dollar tokens. That's basically the same thing, just a different company. I think in the future, I see something like an ad chain kind of like curated registry for all of these different stablecoins that are like backed by dollars based on their like credit rating, and sort of a way to aggregate these into one token so that you're sort of buying a basket of stablecoins. I think that's a little bit further in the future, but that's kind of where I see it going.
Good presentation, and it's great that you guys have a nice go-to-market and everything. And so the question isn't sort of like to correct your go-to-market or anything like that, but it seems to me it's kind of like more of a payments integrated smart meter. To some extent, that's your kind of competitive advantage. Do you have any plans to sort of sell this meter agent thing to other utilities?
Yeah. So the question was, do we have a plan to sell this to other utilities? And to clarify, we're existing parallel to the smart meter. So the smart meter is already part of the household, and that's something that we actually get as our data feed. So that's in a sense our Oracle. That's how it already works. So we actually need smart meters to operate, which is why we can only focus on certain deregulated markets at a time. So the question of do we want to work with other utilities? Yes. We are interested in licensing our software, agents themselves, especially in areas where we can't operate because they're regulated. So I didn't talk about this at the talk, but there are two types of markets, at least in the US. There is a little bit of like gray area in some of them, but we generally have regulated markets where all four of those pieces of the supply chain can be owned by one entity. So what you essentially have are government-sanctioned monopolies. And then you have deregulated markets where each one of those pieces of the supply chain, including retailers, operate at a competitive competitive market. And Texas is the latter. I think California is technically the latter. It's a little bit more a gray area, but we can't operate it in the former, so we absolutely want to partner with utilities. And then also internationally, we want to partner with utilities. Yeah.
What's your relationship, or have you talked to the grid singularity folks at all?
Yeah, so we talked to Grid Singularity. Yeah, we have talked to them. So they are doing a different approach. They are building a consortium ledger with something called the Energy Web Foundation. They're trying to partner a bunch of utilities together to build a proof of authority chain itself. I personally am not a big proponent of private blockchains, and I would like to use the Ethereum network for essentially as a utility, like we talked about. So that is, it's just a fundamentally different approach. I mean, like we've had conversations, and we're welcome to working with them, but there's different approaches. Yeah.
So the grand vision is to kind of create this this systematic change in the energy markets, making it all peer-to-peer eventually. What kind of incentives exist for the other players to go along with this? Like if you take the utility death spiral argument where people are kind of freeloading by using the grid as a battery and that kind of destabilizes it, and whether that's at 2% penetration or 20% penetration, that depends on the lobbying effort in the state. But why would all the other pieces kind of go along with this peer-to-peer model?
Yeah, it's a really good question. So the question is essentially like these regulated markets have utilities where the monopolies don't have any incentive to innovate, basically. I think that's kind of what you're asking. Like, why would they go through this peer-to-peer model? I really don't have a good answer for you. A lot of it comes down to regulation. I think the reason ultimately is that this is just a more economically efficient model. I think we'll get there eventually. Some places will be much slower than others.
Does it address any of the grid stability issues that, like, when you have people like paying net zero because of net metering and something close to it, but no one's really taking care of the distribution network? Like, does this help help solve that problem in some way?
Could you? I don't understand the question.
So again, like the utility death spiral argument, like when like if everyone puts solar on their roof and they're paying net zero for energy because they buy a little bit during the day, during the night they sell back during the day, they pay close to net zero. There's no money to kind of maintain the power poles and like
Yes.
Something goes down. So how does this kind of peer-to-peer reimagining kind of help address those problems which are commonly used against
I'm not sure it does, but I think that there is always money to be made if you own the lines. So you can always charge something to use them. The profit margins may go down, but I don't see the owners of the physical infrastructure ever going out of business because the demand for power is going to go away. So I think it just kind of shifts business models. I hope that answers. Yeah.
So using prepay, the only problem is how do you turn someone off if they haven't paid you? How do you stop them?
Yeah. So good question. How do you turn someone off if they don't pay you, even if they're using prepay? So the way that we're setting this up is that we have the agent paying us every hour or so. If they don't pay us, they get a notification. If they don't pay us for some amount of time, maybe it's like a day, maybe it's 12 hours, something like that, we start drawing down from their deposit. So there's an external deposit aside from the prepaid energy. I kind of glossed over that, sorry. But we eat into that, and then if that reaches some certain threshold, we basically send a shut-off notice. So a lot of utilities do this already. they'll function with a deposit model.
But you guys are going to send them all.
No. We can tell our distributor to not service the power.
This might be a stupid question, but then how do they start up again if their node is running off of their home's power? If their node's not on?
How indeed. I don't know. I guess they could call us. They could use their to pay us.
That's a great question, actually.
Anyone else?
Yeah, so if the internet goes off, does that mean that they can't get power anymore?
Yeah. Okay. So it goes off for like a week. Yeah, maybe. But there's plenty of grace period. So it doesn't need to be on every second day. Theoretically, you could actually run this out of your laptop. So if you just have it on for a couple hours a day, as long as it's on every day.
These devices are going to be sold at a store or shipped by you?
They're shipped by us.
Oh, okay. I was concerned about like if the private keys depended on the serial number, then I could just go to a store and pick out the private keys.
Yeah.
That's great.
Yeah.
I
So
use my private keys to a bunch of different devices and get a lot of
right. Yeah. So the idea is that you can only generate. There's that two-step setup process. You only generate the new private key once someone basically installs that. And to install it, they need to like open the box, like tamper-proofing boxes, and then also you need to actually claim it. So if someone else claims your device, you should probably let us know. Like if it doesn't show up in the mail, and then we'll also notice if no one claims it. So there are some safeguards.
What is the ecosystem around all of the intelligence work? Like you talk about energy arbitrage opportunities. Is it the agent that's deciding to like turn on your IC? Is it like your nest? Is it like a whole ecosystem? Like what is that intelligence?
Yeah. We haven't built the ecosystem yet, but I think what it looks like is the agent sort of like having hooks into the APIs of other devices, or communicating maybe over Zigbee or something like that. But we want the agent to be the central decision maker, to have all the logic kind of living in the agent, because also that's where your trust zone or like secure enclave is. We kind of IoT is notoriously insecure, and we think that there maybe is something to having one device that you know is secure through hardware. Yeah, in the back.
Do you have any strategy around integrating with PUCs and protecting regulated markets?
Integrating with what?
PUCs and regulated markets.
I'm not familiar with that.
Public
So,
utility commissions.
People who regulate regulated markets.
Oh, I see. I do not know. I would have to ask our interview expert about that. As far as we've like worked so far, we are just open to partnerships generally with other utilities. So we haven't gotten there yet.
Okay, so
Maybe one or two more questions, and then we'll wrap it up. So if anyone has any.
So, well, first off, thanks for fielding all these questions left and right. But I'm really curious about the agent because nobody's really tackled the hardware side of it, and it comes with its own set of problems. That it's slow, it's expensive, a lot of support costs with hardware. How did you decide to go with the agent and design that rather than just use a local machine that the consumer has?
We think that, well, so first of all, we want it to be always online because then it can act as a distributed node and it can actually be that missing link to the crypto ecosystem. It's really for consumer simplicity. So if you buy a device and plug it next to your router and never look at it, then that's kind of the experience we want you to have. We don't want you to be always turning on we don't want the average consumer to always be turning on their computer to run their program so that they can pay for electricity. We don't want that like in the forefront of our mind.
Sure.
Yeah.
How would Grid Plus disrupt the energy trading derivatives market, or would even have an impact on it?
Energy trading derivatives market. I don't know if we would have an impact because that's kind of upstream. It's generally with larger amounts. We certainly don't have plans to do that. Yeah.
what do you see as your main competitive
other blockchain companies? So what is our main advantage over other blockchain companies? Consensus has been working on projects in the energy space since before the public Ethereum network was launched. So we have a lot of expertise, specifically around energy problems. We have a lot of contacts in the energy space. Consensus has lots of really, really smart blockchain developers who know this ecosystem, know how to use the technology properly. And I think that we are just in a good position. I also don't know a ton of other blockchain-based companies that are disrupting energy markets in the same way that we are. There are other approaches to do like microgrid payments and stuff like that.
All right, last question.
You mentioned that you were interested in pursuing the agent model to gain efficiencies on the payment side as well as connecting directly with the wholesale markets. And you mentioned that wholesale market connection and efficiencies would come by exposing the agent directly to the prices and gain efficiencies from that. I wanted to ask how you were interested in transmitting that sort of dynamic price to the consumer. In this case, you mentioned integrating with some of the devices in the ecosystem. How else were you planning on getting the agent at the end of the node to respond to some of the prices?
So the wholesale price is publicly broadcast by independent systems operator. So that just looks like a public API. As a retailer, we have exposure to that, and that comes with both the real-time and the day-ahead markets. And then also some of the other markets, like dispatchable load markets and stuff like that. The agent is, at its core, just you can kind of abstractly think of it as a decision maker based on that input data. And then also any data feeds relative to like the consumer demand. And it will purchase based on how much they want and what the prices are per quantity. It will just purchase.
All right, thanks everyone, and can we give a round of applause? I'd also like to give a shout out to all the other meetup organizers, Linda, EJ, Arjun, Ron, everyone else. Thanks for coming, and also the Consensus interns for helping set up, and also Digital Garage. So yeah, thanks guys, and we'll be meeting at, if any of you want to hang out later, come to Murphy's Pub. It's at 217 Kearney Street. That's just a few blocks away. And feel free to hang out here a little bit too. And yep, thanks.